of the home applications and consumer electronics and medical devices and aerospace vehicles and automotive vehicles. To understand this microcontroller in detail, so how this microcontroller is classified is based upon the some of the factors. So it should be it has the bandwidth. So the bandwidth is specifically it will be defined how many bytes of the data it will be carried on the bus. So we have the 4-bit and 8-bit, 16-bit and 13-bit. These are the bits. It will decide the bandwidth. So 8-bit microcontroller, specifically the CPU process the 8 bytes of data at a time. So and 16-bit is specifically 16 bytes of data will be processed at a time, and 32 is specifically it processes the 32 bits of data at a time. And similarly, it has the architecture. The architecture is the Harvard architecture and one Neumann architecture. So this is also called as the Princeton architecture. So here, the understanding about the hardware architecture, like it is a microcontroller that has a separate memory storage and signal path for instructions and data. And this can be improved efficiently on based upon the instructions, and data can be accessed simultaneously. And we have the one human architecture. It can process both instructions and the data that's stored in the memory. So it is a simple but less efficient than the hardware architecture. And another part is the instruction. So we have the CISC and RISC kind of instruction set based upon the data that we are giving to the hardware. So this will be decided. This RISC and CISC, it is a part of the memory storages. And we have the memories. We have the external memory and the embedded memory. External memory is all for the microcontroller. We are configuring externally to the hardware, the memories, and embedded memory is a combination. It will be configured within the microcontroller. So these are the memories. It heavily can place it. There are many families. They started manufacturing the microcontrollers. Like 805 is the one which evolved first. The Intel, later Motorola. They started working on the microcontrollers and designing of the microcontrollers, and the Texas, Dollars, and Philips, and National Instruments, ARM, and Siemens. So there are many other manufacturers. They started working designing of the microcontrollers, and they own architectures. And how these microcontrollers will be added on the programming side. Usually, the microcontrollers, it's a part of the designing of the hardware. So initially, the hardware should be designed based upon the architecture. So whether it will be the hardware architecture or the one and the architecture will be I think. Okay. Circle. Yeah, fine. The topic is about the microcontroller. So we need to understand about the background of the how the microcontroller is involved and what are the activities it will be taking a place and towards the embedded system. So microcontroller, it's a part of a small integrated circuit. So it will be sometimes it will be part of a IC. We say as an integrated circuit. So the ICs it is specifically designed to perform specific tasks. So what is a specific task? The function to take the reading of the data from the sensors or to make the rotation of the motor. So it will be a part of a specific task with just it will be say that it should require to process some data. So what it will involves the microcontroller typically consist of the CPU, that is a central processing unit, and we have the memories. Like the memories are like the RAM and ROM and some of the flash memories, and input type output ports, and the peripheral devices. So which are integrated on a single chip to work on the specific task. So this will help for in many home applications and consumer electronics and some of the medical devices and the aerospace and automotive division. And what is the future of the microcontrollers? So generally, the future of microcontrollers, it should be integrated. It will be integrated with the components like CPU, ROM, and flash memory, and some of the analog to digital ADC. We say ADC we have and DAC. So these are the converters to convert the data from analog to digital or digital to analog. It will be a part of one port, and we need one lower power supply. So to maintain the ideal voltage for some of the applications, and it should be in a small size. Depends upon the application which we use, and cost should be reasonable towards the hardware or the functionality of the software. It will be decided the cost, and some of the examples for that reasonable price we can get it is the controllers or Arduino controllers and PIC, Atmega, and STM32. So these are the some examples to know about the microcontroller. And microcontroller is specifically to automate some of the features automatically with the help of some sensors that we are able to configure. And what are the typical involved in the microcontroller? So we have a bus width or the bandwidth we say that will be decided depends upon the bit that we configure and that we choose. So we have a 4-bit, 8-bit, 16-bit, and 32-bit. So 4-bit means 4 bits of data can be transferred at a time. 8-bit means 8 bits of data can be transferred at a time, and 16-bit means 16 bits of data can be transferred at a time. So it depends upon the hardware which we choose. Let's take example of a 8-bit microcontroller. So 8-bit microcontroller, we can say the 8051 and PIC controllers, and 16-bit is the PIC 18, and 32-bit is STM32. So it have a difference, and 32 we well known is a ARM Cortex. So it is we have the variants like M and other variants. So these will be there will be a difference on the hardware side on the bits level. The bits which it will transfer, it will be decided by the bus width. So bus width or the bandwidth we can say. And next will be part of the hardware that microcontroller we chosen should be the architecture wise. It should be the one human and architecture hardware architecture. What it will be the hardware? Hardware is specifically the it will be the memory storage and the signal path. So signal pathway, it will be a separate signal pathway for instructions and data. It will be the separate and the one Newman architecture, both the memory storage like for program instructions and data storage, it will be in the same memory, and it is a simple compared to the hardware architecture, because the hardware architecture it will be maintained separately, but one it will be architecture the access the same memory for the instructions and the data, and it is a simple compared to the hardware. It will be the hardware will be the complicated, and one is very simple. So, and we have the processing of the data. We have a instruction set. So it have the sys and RISC. So, and next will be the part of a memories will be differ in the microcontrollers. So whatever we are choosing, it should be the external memory, or it will be combined with the with the microcontroller. So that should be consider. So external memory is specifically like for the hardware, we are interfacing the memory externally, and embedded memory is specifically for the microcontroller, we are embedding the memory on the microcontroller. So there are many companies are started designing on the microcontrollers. So different architecture, different set of instruction set and the memories and the bits. So like initially it was the Intel company, and the later Motorola, they started designing of the Atmel controllers, and Dallas, some of the companies we started working on the big controllers, and like Texas, Philips, National Instruments, and Siemens. There are many more companies they started designing of different microcontrollers with different architectures. So like that, the hardwares are emerged. The initially how this microcontroller was introduced towards the market is the history we should know. So in 1981, the Intel introduced the 8-bit microcontroller. So that is a 805 microcontroller. This is one of the most popular and most commonly used microcontroller in a various field in the embedded systems and consumer electronics and automobiles. And next will be microcontroller. As we know, it consists of the CPU and the RAM and ROM and IO ports and serial ports and timers, interrupts, and clock circuits. So it is a combination of multiple electronic components on the single device, and it will be named as a 805 microcontroller. So and next is it is a part of a hardware architecture. So as we discussed, hardware architecture is a microcontroller that has separate memory storage and signal pathway for instructions and data. It has the separate memory. This improves the efficiency on instructions, and data can be accessed simultaneously. It will be a faster hardware architecture. It will be the faster. And next will be the part of basically this 8051 microcontroller was developed by using a HMOS technology, which requires more power to operate. So therefore, Intel again they redesign this microcontroller uh, with CMOS technology, and they updated the version as a 80C51. So that is the second version they updated. So to understand 805 in detail, like what are the how what are the pins and ports configuration, what are the how the power supply will be enabled, how the connections is happening, we need to understand about the pin diagram. So usually this will be part of a 8051 microcontroller. So inside it has some logical connections where the devices will be interfaced and interconnected with each other. So it is a 40 pin device, so which have a 32 pins are used for the IO connections, and the 24 pins are dual purpose. They can operate as a IO, and we can use like a control line as well a part of the address and data buses. So we need to know how this bus connections is established with the microcontroller. So if we go in deeper, like these are the ports connection, and we have a reset port, and we have a transmitting pin and receiving pin, and we have a interrupt pins, and we have the timer pins, we have a read and write enable, we have the clock oscillator clock pins, and ground. So we need to understand in detail about how these interrupts are configured, and read and write of the serial data, and some of the ports configuration, analog data and digital data will be enabled, and the main power supply pin will be the 40 pin, and we have the address latch enable. So and we have a PSN support enable. These are the some of the pins which configured on the 8051. So usually like it is a 8-bit ALU automatic logic unit. It is the heart of the microcontroller, means here it is a CPU. It performs the arithmetic and bitwise operation on the binary number ALU. And next will be we have a bit accommodator, and it is important register associated with the ALU. And the RAM is 128 bytes of RAM is used for the input and output registers. And ROM, we have a 4 KB of on-chip ROM, that is a program memory, and IO ports like 8 bits input output ports, which are used for the addressable reading of the data or the sending of the data. and that is the IO port. So it is a bidirectional where it can send and receive the data, and timers and counters. So it is a 16-bit timers counter used in 8051, and it has a serial port where it supports the full duplex communication. To communicate with the other devices, use the UART communication protocol. And external memory is specifically the data which interfaces, whether the RAM or ROM memories. And we have additional features, the interrupts, on-chip oscillator, and some of the power down modes to make whenever the hardware receives the high power, so it will be uh, get the problem, fault or failures can be created. So to avoid that, there will be limited power will be supply, that will be the power down mode features. And next, it depends upon generally generic. This is a part of a generic information, and it varies depends upon the manufacturer to manufacturer. The timers or the serial boards or the RAM and ROM storage and the external memory storage, it will be varied. And we have the P1 and P2, like the whatever the IO pins, 40 pins. Just we need to understand like P1 to P8, the pins which are a bidirectional pins. It doesn't perform any task. It just a IO connections. And P9 is a reset pin. It is used to reset the microcontroller. So, and next we have a pin 10 to 17. So pin 10 to 17 is a part of the 8 pin bidirectional IO port. So it performs some part of operations. So we have the interrupts, we have the read and write pins. So, and we have a transferring of the data, TX and RXT. So with the help of this, we can able to do. And we have a pin 18 to and pin 19. So that is a clock pins. With the help of this, we are able to operate the clock, change the clock, like it will be like 4 megahertz to 30 megahertz. Depends upon the process. The process is speed will be dependent on this oscillator mostly. And we have the pin 20 is the ground. So every electronic component require the power, and the power have the positive and negative. So the negative here terminal will be ground here. It will be connected. It should be provided with a zero power supply, and it is a negative terminal for the power supply. And moreover, pin 21 to 28 here. So this will be operated for the external interfaces, or external interfaces like memories or any part of devices to be connected. It is a bidirectional pin where the data will be transferred here. And the next will be a part of a pin 29. So this will be a part of a program storage enabled PSCN. So it is an output where it will activate the low pin. It is used to read external memory, and it hold the program code whenever the pin is connected to the other part of memories. And moreover, we have a pin 30. So it is a address latch enable. It is the input. So PSCN is the output, and it is the input pin, and it is a active high pin. Generally, it is used to distinguish between the memory chip and the other multiple devices where it will be configured. So it is used to read the program data whenever the data you are flashing into the hardware. So pin 31 is nothing but the external access input. It is used to enable or disable the external memory interfaces, and it is connected to specifically for the voltage. Some of the memories required the power supply as well. So to store some program data. So this will be a pin 32, and pin 32 to pin 39 will be a part of the bidirectional pins, where it requires some additional configuration, where like it internally it have a pull-up resistors. So where the data you are able to send and receive via the pins. So it is used for exchanging of the information. And next we have the power supply. So here the pin will supply plus 5 volts. That is the initial phase of the controller which defined. So this is the pin diagram of the microcontroller. And what are the issues you will face towards the microcontroller in 8051? So initially, that is a part of a power supply. So usually, it should be operated with the 5 volt supply. If it is not stable, the microcontroller it won't give proper data. So next will be a part of input output current. So whatever the data, the current you are able to supply to the device, it should be operated within the range. If it is exceeding, then there will be a chance of damaging the microcontroller. And the input output voltage is similar. If it is voltage is too low, it cannot, whatever the code it present in the microcontroller, it cannot be operated. If it is too high, even though some of the inputs and outputs cannot work. So, and we should be maintain the normal voltage and normal current to work on specific application. So interfaces, we are whenever we are interfacing to the additional devices like some of the motors or the sensors. So the wiring is needed. So with the when the wire, whenever the voltage and current is carried, so that time there will be electromagnetic force. The EMF will be generated. Due to that noise, even there will be a chance of getting the disturbance of the data. So it should be properly shielded whenever we interfacing the devices or components to the controller. And pin conflict, if you use the wrong pin configuration, then the proper data cannot be monitored and proper data cannot be sent to the respective devices. So we need to ensure and we need to be carefully connected towards the circuit, and we should avoid the incorrect pins, and we need to ensure that functionality, whatever the functionality that we are expecting, it should work. So we should have a proper pin connection. So what is the use of pin diagram? So mainly we can interface with the external devices. We need to ensure that the sensors or the motors or the displays or the communication modules to communicate with one to other modules. It will be easier. So, and the main, what is the main function? Like where to read the sensor data, and based upon the sensor data, we should get some display. So these are the some interfaces is required to communicate, and programming of the data. So based upon the language that we retain, so the logic we retain, like C or any kind of programming, it requires some logic. So based upon the logic, the inputs and output can be controlled. So we have the language like programming language like such as assembly language and C and some of the basic, so that can be supported for the microcontrollers, and where we have a PSN pins and the ALE pins that are used to program the controller. And we have a debugging and testing. So mainly debugging and testing is a part of checking the functionality whether it is working correctly or not. So we have the monitor signals and some of the analyzer tools that can be used, and oscillators where we can connect the oscillator pins to the respective hardware pins, and we verify graphically that signals are able to update properly or not. So that can be possible by doing the debugging and testing. The debugging is specifically identifying and fixing the issues, and testing is like checking whether the actual and expected values are met or not. So like debugging and testing are major factors to verify that proper pins are working. And the expansion and customization, so moreover, based upon the customer need, the hardware will be specifically designed, and the programmed it will be tested as a part of the requirement. So, and additionally, like memory interfaces are required, the memory or any IOS configuration that when we connected to the microcontroller, we can enable more features to operate in the real-time conditions. And overview about the microprocessor, because microcontroller, as we understood that it is a part of integration of the CPU, IOs, timers, and oscillator. So, and we need to understand about what is a microprocessor. So, microprocessor is the one which is a part of a brain where it supports most of the data will be processed uh, from the inputs and outputs that we receive. So here the microprocessor is a general purpose processor. It is used to perform uh, complex computing tasks. So and specifically, it doesn't have any internal memory or peripherals. Usually, microcontroller have the internal peripherals and the memories, but microprocessors it don't have. So only it can process the data whenever the data is getting. So how this microprocessor is differ? So it have the difference with the interface connections. So it is a it have generally it doesn't support any memories and IOs, and even it doesn't require any components within the microcontroller. So microcontroller it have all the components, whereas the microprocessor it don't have those components. And what is the purpose of the key features of a microprocessor? General purpose. Generally, microprocessor is designed to handle a wide range of tasks, make it suitable for running the operating system, and moreover, our more laptops or the mobiles. So it will be a part of the microprocessor where it can handle the complex applications like gaming and office softwares and data processing and high processing powers. Microprocessors are more powerful and designed to perform complex and computational and multitasking. So it requires external component. Microprocessor need extra. We are connecting externally the RAM and ROM and timers and IO ports, and where we can increase the complexity and size of the system. Microcontroller is a fixed one. Once if you design it, we cannot modify. But microprocessor is additionally we can configure, we can increase the size. And moreover, the microprocessor is a complex system. Based upon the requirement, we are able to interface our components like our personal computers, smartphones, servers are the examples. And moreover, whenever the components are increases, uh, the microprocessor size or the complexity will be increased. It is a high power consumption. So examples of the use of microprocessor. So examples is Intel Core i7, i5, i9 are the processors as we are familiar with our laptops. So whenever we go, like we see the what is the Intel Core i5 or i7, i9. So it is specifically the processor, and we have a ARM Cortex A series. It is used in smartphones and tablets, and the AMD it is used in gaming and desktop computers. Commonly used cases of this microprocessor are the personal computers and laptops and mobile devices and gaming consoles and some of the high-end servers. So these are a part of the microprocessor. So we need to understand about microcontroller in detail. So what are the components it have and how the data will be processed. So we should understand in detail. So to understand the microcontroller in detail, like microcontroller is a integrated circuit. It's specifically designed to perform a specific task in a embedded system. So as we discussed, it includes processor, memory, peripherals like IO ports and timers and communication interfaces on a single chip. It will be integrated. And we saw that 8051 microcontroller. So in 8051 microcontroller, we have a 40 pins. So for that 40 pins, the connections will be like it have the oscillator. So oscillator is the one. It is a heart of the controller, and the CPU is the brain. It is a processor where it will process the data that we are receiving it from the sources. Like it will the interrupt controller will be external interrupts, or we have two types of interrupts: hardware interrupts and software interrupts. So that will be given directly to the CPU, and we have a ROM and the RAM, and we have a timers, and we have the serial control where the serial protocols are configured to the serial control to exchange the information, where TX will be the data we are receiving from the controller, and TRX is the one where the hardware is receiving the data from the users or from other devices. We have a TXT and RXT, and we have a parallel ports, four IO ports are there, and we have a bus control where we are able to control the complete system. We have a ALA and PSCN. Those are the pins that will be connected to the bus controllers. So this data, whatever the data, it flows to the RAM and the ROM that will be processed by the CPU. Next, what are the components in the microcontroller? So the components in the microcontrollers are central processing unit, CPU, memory, input and output ports, and clock and timer circuits, peripheral interfaces, timers and counter, interrupt controllers, and watchdog timer, and power supply, debugging interfaces, and specialized peripherals. So whatever the above diagram, the flow of CPU and ROM and RAM memories are configured, and we have the interrupts configuration and oscillator. So we need to understand in detail how the CPU will be processed data and what are the types of memory, what are the IO ports, like we have a parallel ports and serial ports. We need to understand how the ports are communicating, and the clock and timing. So we have the clock, the timer T0 and T1. So what is the purpose of the timer? So the clock and timing we need to understand, and peripheral interfaces. And the clock and timing circuit is similar to the timer and counter, and we have a different block for it to ensure the data that will be counted, and interrupts collect controller and watchdog timer. Power supply is the one which is required to enable the complete hardware. And debugging interface, we have a specifically debugging pins to check the complete system, and we have a specialized peripherals. So to understand about all this in the microcontroller, the first page is the central processing unit. So the CPU is the brain of the microcontroller, where it is responsible for executing the instruction from the program which stored in it, and it performs arithmetic and logical control and IO operation. And next is part of 8-bit or 16-bit or 32 will be decided by help of the CPU. So how this CPU will be decided? So the CPU, it have internally the bus. So the bus where the data will be fetched the information from the memory, and it will be decoded, and it will re-execute the instructions, and that data will perform some arithmetic logical operation. So that's how the CPU will be processed. So this data will be accessed from the memory. So memory is a part of the data storage. The instructions will be whatever the programming logic that we are writing, and whatever the data we need to process, that will be stored. So here the memory is in microcontroller. Is a microcontroller typically includes multiple types of memories, RAM and ROM and EEPROM memory. So to store the instructions or data or the variables. So we have memories of ROM memory, the ROM memory, or we call it as a flash memory as well. So this memory is used to store the program code. It is used to store the program code. We call it as a firmware as well, and it is a non-volatile memory. It is a non-volatile memory, and it cannot be erased even if the power is off. And we have a other part of memory is a RAM memory. RAM memory, that is a random access memory. Random access memory. So it is a temporary storage. This will be a part of a temporary storage memory, and it is used to store the data. The process is currently working. Whatever the data that we are working currently, so that data will be stored in it, and it is a volatile memory. Whenever the power is lost, the data will be erased. And we have a other part of memory is EEPROM memory. So EEPROM memory is a electrically erasable memory. Electrically erasable, programmable ROM memory. So it is a non-volatile memory. It is used for a small amount of data can be stored. Small amount of data can be stored. So this memory, the data will be updated occasionally. And to understand these memories, so memory we have read-only memory, flash memory, and the EEPROM memory. So these are the typical memories which involve, and we have the IO ports. So mainly the microcontroller is designed specifically to control the inputs and outputs. So in diagram we are able to see we have some of the transistor sensors, and we have the other sensor, LER sensor, and we have the switch, and we have some part of pressure sensor and temperature sensors, and we have outputs like speaker, LED, bulb, or buzzer, or the motor. So these are the outputs which are connected to the microcontroller. So microcontroller, we have programming. So the program will be written like whenever the switch is on, the bulb should on. So like the logic program will be written in the code that we are programming it to the controller. So based upon that logic, the inputs and the output controlled automatically. So the here we have digital inputs. Digital pins used for binary signals. It have on and off, high and low data. And we have analog inputs. Analog inputs are used to read some of the real-time data from the sensors and to activate the signals. So similarly, we have analog inputs and analog outputs. To convert this data to understand the hardware, we have the analog to digital converter and digital to analog converter that are interfaced to the analog sensors and actuators. And similarly, we have the timers and counters, so which is used to count the external events and to check that the delay, without delay, the data will be sent to the LEDs, to the bulbs, based upon the input, how we are able to control it. And we have a timers and counters. So timers or counters are used to generate the delay. So I need to send some data, some like 100 milliseconds of time after or before. So that timer, based upon the setting of the timer will be data will be saved in the memory, and it will be triggered or at the part of some intervals of the time. So it is specifically we are scheduling and we are making the to send the data or to read the data. So microcontroller just often have a some sort of built-in timers. It is used to count and help to manage the time. So it used to operate on the delay part, on some of the pulse width modulation, and to measure the external events. And mostly whenever we press the button, so the signal will send the trigger. So it is a part of the timers that will be configured in the microcontroller. And the clock and timer circuit. So whatever the data we are sending, or it will be transmitted in the controller, it should be synchronized and it should be executed one after another. So that event will be taken care and it should be communicated with respect to the clock. So data cannot be overloaded every time. It should be executed one after another. So that will be decided by the microcontroller CPU. So where that data timing is synced with respect to the oscillator. So controllers have the internal oscillator that will be a part of a clock. We can say it is a part of the microcontroller where it sends continuously the clocks. With respect to the clock, the data will be decided. So here the clock speed is measured in terms of megahertz, and where the microcontroller processor will be uh, whenever we set the high process clock, the higher means the processing of the processing data will be also faster. So that's how the clock timing circuit will be decided. And microcontroller often it have a built-in peripheral interface to communicate with the external devices like UART or user. You know these are the protocols. With the help of the protocols, we are able to communicate the data or exchange the data. So UART is a universal synchronous and a synchronous receiver and transmitter, and it is used for connecting of the Bluetooth devices or GPS models and some of the PCs. And we have SPI, serial peripheral interface. This is the one protocol. It is used for fast communication to the sensors and displays and memory devices. And next we have I2C intra-integrated circuit. This protocol is used to connect multiple devices over a short duration of time to read the sensor data on the phone. And CAN protocol. So mostly this CAN protocol is the faster compared to the above protocol, and it is used to configure with multiple hardware, and the data can be exchanged very quickly. And we have a USB. USB is also one part of protocols, universal serial bus. So it is used to communicate with the computers, and when whichever the devices it have the USB enabled, so that can be configured and connected. And we have the interrupt controllers. So interrupt controller is basically the disturbance is created towards the hardware or software. So it microcontroller supports the interrupts, which allows the device to respond immediately to the external events. So whenever the interrupt occurs, the microcontroller the main program will be suspended temporarily, or it will be halted the current task, and whichever the interrupts has came, so that taken a priority. Once the interrupt task is completed, then it will return to the previous task. So the interrupt is a part of the hardware interrupt or the software interrupt, so which allows the microcontroller to respond to the event which it triggered. So without any waiting time, so it will be executed. So here the ISR is the interrupt service routine. It will be taking the responsibility uh, to pull the data, whatever the input we receive. So that will be decided. So interrupts can be externally triggered or internally generated. It depends upon the hardware and the complexity of the program. So we have a watchdog timer. So watchdog timer is specifically the safety feature. It will reset the microcontroller if the program is running infinity, or it got hanged, or it is not responding properly on time. So watchdog timer is a one pin. Like when we enable it, so this will reset the complete microcontroller. It helps to prevent the system from freezing or crashing in the real-time condition. So this watchdog timer is a safety feature. So it always resets the microcontroller if the software gets stuck at any infinity loop or a malfunctions. Where it ensures that systems remains a responsive all the time. So system should get a response whenever it got stuck with any part of the uh, file unit. So, and moreover, our hardware requires the microcontroller requires the power supply. Without power supply, the microcontroller cannot operate the inputs and output conditions. So here the voltage have different voltages depends upon the hardware or the um, hardwares or the functionalities that we configure. Like the voltages will be 3 volts or 5 volts or 12 volts or 24 volts. So it will be operated depends upon the complexity of the component or the interfaces. This voltage will be decided, and some of the microcontrollers it will be operated at a low power mode, and some when there is a no functionality or it's in a not operative mode, it should go in a sleep mode and to save the energy. And specifically the power is continuously, the battery should be configured at some conditions where it supply the minimum voltage to work the functionality. And we have a debugging interface generally used to configure with the JTAG, and serial wire debug cables will be there. With the help of that, we are able to debug the programming, and we are able to make the system to work. So generally the microcontroller programming we are able to do with this JTAG and serial wire debug. So here we require the development tools. So to write our program, the basics things we required is to write the program. We usually say IDE. So IDE is the integrated development environment. So where that can be happen, for depends upon the hardware. This IDE will be differ. Arduino IDE and MP Lab. Uh, so this is for Keel, and we have the Keel UVision. So these are some of the IDs. In this, we able to write our program, and we are dumping into our hardware. So whenever we means the dumping here is the flashing. So flashing or sending, how we are sending the code, whatever we written the code, we are dumping or debugging or flashing can be done via some of the tools using the JTAG and serial wire or the serial wire debug tools. And to flash, to make our code efficiently, we need the bootloader. So bootloader in microcontrollers, it which allows for easily reprogramming without any needing a dedicated programmer. So this commonly some of the hardwares usually have defaults. Some hardwares we need to modify the bootloaders, where depends upon the application software which needed. And we have a firmware. The program written for the microcontroller is often called as a firmware. It typically interacts closely with the hardware, and it is a major functionality that we are able to do it via the coding. So it allows to developer to test and monitor the debug the microcontroller and internal state when the program is running. So with the help of the firmware software. And the specialized peripherals depends upon the applications of the microcontroller. We have designed specifically to interface the components. We have the pulse width modulation controller, where we used to connect the mode controllers and light LED bulbs to and some of the speakers uh, to trigger. So requires the pulse width modulation. We have a touch screen. So that are the inputs where we it will capture our data. So with the help of the sensor. And real-time clock RTC, it is a separate clock module that keeps a track of data. So the hours or the minutes or seconds. So that system have internally the timing. So that will be calculated when it power shutdown or when the power is active. That will be controlled. And what are the key features of microcontroller? So the mainly the key features of microcontrollers, it will be integrated with the peripherals, and it is a self-sufficient since it all necessary components like CPU, it are integrated on a single chip. It is easy to design for standalone applications, and a lower power supply. So it depends upon the application. The the power consumption will be decided. And some of the real-time applications will be used, depends, and it has a limited processing power. Typically, some of the microprocessor or controllers, it requires only less power consumption. So commonly used microcontrollers in are the AVR, Arduino controller. It is some of the robotics or some of the home projects. We use this Arduino and PIC controller. It is used in consumer electronics. ARML Cortex M series, widely used in embedded system, and commonly uses microcontrollers are the home appliance, like microwave or washing machine. Automobiles like ECUs. ECUs will be airbags or the engine ECUs or the battery ECUs, and IoT devices, and some of the automation tasks we use, and even in the medical devices will be used in the as a part of a microcontroller. And what is the difference between the microcontroller and microprocessor? So as we understood that microcontroller is a it have a combination of all the CPU, timer, RAM, and IO, ROM are combined on the single chip, and microprocessor where the CPU will be on separate. We are integrated. We are the timer outputs are serial interface, ROM, RAM, and inputs are we are externally we are connecting to the CPU. What CPU usually have? It have a ALU, arithmetic logic units, where the data will be uh, controlled and processed with respect to the data which we receive. And the major difference between the microcontroller and microprocessor, so the integration level, the CPU, memories, and peripherals are it will be on a single chip. But CPU, it have only CPU. We are connecting externally the memories and IOs if needed for the microprocessor. So this will be part of the microprocessor where we are connecting externally, and we have the complexity. So complexity microcontroller, it has a simple and low cost and it will be single task operation, and depends upon the application. We are able to increase the complexity and multitasking, and requires more hardware support. Application here, it is embedded system and the control oriented task will be performed, and this will be a part of a general purpose computing high performance system. Microcontroller is a low level power consumption, and microprocessor is a high power consumption because externally we are able to configure it, and processing wise, the microprocessor it will be the high processing power, and microcontroller it have the limited processing power supply. So these are the major difference between the microprocessor and microcontroller. And how to create these embedded devices. So we need to learn the programming language, and we need to see which type of board we are choosing, and we need to know like what is the program we need to configure to the hardware, and what is the hardware we are selecting. For that you need to select your ID based upon your hardware. You need to select whether it is Arduino or the Keel or MPLAB. So whichever the ID, that ID you should be chosen. You need to write the code. Then you need to uh, flash that code into the controller, and then you need to test, and your project will be ready. So means your embedded product will be ready. How to program the microcontroller? So generally we need to understand about this input devices, what are we are connecting, and we need to understand what are the outputs we are able to operate with respect to the input. On the inside microcontroller, we know that CPU, memory, and peripheral functions, and it should be configured, and we need to give the instructions based upon the address, and we need to write the logic of the program in the C or assembly level language, whichever the hardware support. And nowadays the programming is supported with respect to the Python as well. So with the help of the Python, they able to operate the inputs and output condition. So like we need to understand the hardware, the language for the hardware, which hard programming it will be supported. So based upon that, we need to configure the inputs and the output devices. Then the language which we are making it, if it is a high level language program, the machine always understand, the controller always understand in a lower level language. So how whatever the data, the programming we are writing in the code, it should be converted to binary language in a format to understand the code. So initially, in the IDE, Integrated Development Environment, where the program you written, so that will generate the .bin or .x files. So because our hardware can understand and take the data only the hex file, so that hex for the hardware, just we are flashing the code, we are uploading the code, the hex file or bin files into the RAM memory. So then the display or the motor, it will be started function. So that's how the programming we are doing to the controller. And for IDE, like how we are able to enable the program. So first in IDE, we need to write the code and we should process the data with the, whenever we are writing the code and in the IDE, we start compiling, it will pro, uh, compile the complete source code and it will take the linkages. And finally, the loader will be the one where it generate the dot files. So, and we have executable file. So the CPU, whatever the microcontroller we choosing, the input files or output files, that executable will